If SAT questions like this one are still throwing you for a loop, you've come to the right place. In this video, I'm going to go over everything you need to know about trigonometry on the SAT. So before we get started, we really need to talk about SOH-CAH-TOA. And SOH-CAH-TOA is going to be your bread and butter of trigonometry-based questions on the SAT. So we're going to use see what I did there? We're going to use SO as our example to start. The first letter in each of these 3-letter groups is going to stand for either sine, cosine, or tangent. So the S is going to be sine, and then we have the letters O and H and A. O is going to stand for opposite, H is going to stand for hypotenuse, and A is going to stand for adjacent. So you take your first letter, either sine, cosine, or tangent, you say that it is equal to your first letter, remember O was opposite, divided by your second letter. Remember H is hypotenuse. And I'll remind you what the hypotenuse is in just a second if you forgot. So that would be the SO, right? Let's talk about CAH. So if you remember, C stands for cosine, and then the next step would be equals. Then we have A, which is adjacent, divided by, again, hypotenuse because of the H. And then TOA, remember T stands for tangent, equal to, next letter O, so we would have opposite, divided by adjacent because we have an A. And this is the most important thing for you to memorize when it comes to trigonometry questions on the SAT. The SAT doesn't really get that in depth with trig, which is nice, but this is one thing you definitely want to know. All right, let's talk a little bit more about what this looks like on a triangle. So we're not going to do the problem yet. First, I just want to explain some things. Let's forget about what's being asked, and let's just focus on this angle. So angle X, if we wanted the sine of angle X, it would be opposite, and opposite means across the street. So our angle is in the corner, we go across the street, and whatever we're pointing at, that's our opposite. So in this case, it would be 16. Let me change colors here, actually. 16 divided by the hypotenuse. So a hypotenuse is going to be the longest side of a right triangle. The longest side of a right triangle. And if you aren't sure which one the longest side is, it's always going to be across the street from the 90-degree angle. So we've got our 90-degree angle here, across the street, we've got our hypotenuse. So that's 23, right? So that would be 16 over 23. What if we wanted to know the cosine of X? Well, we go here, it says cosine would be adjacent divided by hypotenuse. Adjacent means right next to. So our corner's here, and obviously there's two sides right next to it. There's this one and there's this one. But what adjacent means is the one that's next to it that is not the hypotenuse. So it would just be this side here, which we don't know. So we're just going to call this, we'll call this Z, just for fun. So then cosine would end up being adjacent, Z, divided by hypotenuse. We already know the hypotenuse is 23, right? And then the last one, tangent, again, just looking at this angle X, where's opposite? We already defined that as 16, divided by adjacent. We know that adjacent, whoops, I forgot my label. Adjacent we were calling Z, so that would be 16 divided by Z. So that's an example of what all of these would look like. And again, I was just using it for this angle. If we were to be looking at the other acute angle, acute being less than 90, this one over here, then things would change, right? Opposite would now become this. Adjacent would now become this. The only thing that remains the same is the hypotenuse. So hope that clarifies SOH-CAH-TOA for you. Now let's use it to actually get our answer. In the triangle shown, what is the value of sine of x? Well, we already did the work, right? We determined that sine of x was 16 over 23. So that should be our answer, and we could actually move on. All right, for this next one, I definitely want you to give it a go. Try and do this one on your own first before I share the answer. I've written SOH-CAH-TOA letters up there for you, so pause the video and see if you can get the answer. And I want to see if you can get the answer without actually writing anything down, just as a little challenge. All right, so let's talk about it. It's asking for tangent of A. Tangent means opposite over adjacent, and it's the tangent of A. So looking at A, opposite is 20, adjacent is 21, so it should be 20 over 21. C. All right, let's bring this up to a new level here. This one, we do not get a picture, so I think that makes it a little bit more challenging. They're asking us about similar triangles, so we also need to know what those are. And just to give you a refresher, a similar triangle or two similar triangles are triangles that share the same angles, which means they are proportional. So we can talk more about that as we work through this problem. So it's saying there's triangle ABC, and it's going to be similar to triangle DEF. And then it tells us how they correspond. We'll go over that after we draw them. It's also telling us that the length of one of the sides of the first triangle is 2.9 times the length of the other one. Let's just start drawing these out first. We know that they're both right triangles because it does say, they both have right angles, and angles C and F should be at our right angles. So I'm going to say, forget what these angles are. We're just drawing to draw. Okay, so we've got a right triangle here, and I'll go ahead and label this, making sure that C is our right angle. And we'll just put A up here. And to be clear, A and B can switch places. I'm just deciding to put them here, but it doesn't really matter as long as they match up with the other triangle. Speaking of which, let's draw our other triangle. We'll change its color just to, and this one's going to be bigger, remember. So just to visually make ourselves happy, we're going to make this one bigger. And even though they don't have the same angles the way I drew them, we're going to pretend they do, right? So let's make sure that everything corresponds correctly. They said A corresponds to D. So this is going to be D since it's A on the other one. F is the right angle, so F is down here. And that leaves us with E, which is going to be over here. Cool. It's also telling us that basically this whole triangle is 2.9 times bigger, but I don't know if we're going to care about that because it's asking us about SOH-CAH-TOA, right? It's asking us about the tangent of one of these, which means we're really just worried about angles. Basically, if the tangent of A is 21, so I'm just going to erase this because I don't want us to get distracted here. We really don't care that much about this. Hold on, let me make sure we can actually see the whole triangle I drew. Sorry about that. What it's telling us that we do care about is that the tangent of A is 21 over 20. So tangent of A, remember tangent, and I didn't write SOH-CAH-TOA this time, so see if you haven't memorized yet. Tangent is TOA, opposite. So opposite is 21 divided by adjacent, TOA, 20. So that ratio is going to stay the same on our other triangle. So even though FE is technically 21 times 2.9, the ratio is still going to be 20 to 21, right? When it asks us the value of sine of D, we can still use these numbers. So sine, so opposite over hypotenuse, so it would be 21 divided by hypotenuse, which we don't know. So it's 21 divided by the unknown side. Now, if you know your Pythagorean triples, you're going to know that 20, 21, 29 is a common Pythagorean triple. So our answer would be 21 over 29. If you don't have that memorized, which a lot of you probably won't, we just use the Pythagorean theorem. So what would that look like? Let me grab a new color. A squared plus B squared equals C squared. A squared plus B squared equals C squared. Just remember that A and B are your legs and C is your hypotenuse. So we could say 20 squared plus 21 squared equals C squared. I'm not going to do the math right now, but if you calculate that, you will indeed get 29 as your answer. So there you go. All right, we've got another one that includes a drawing here. Again, I recommend that you pause the video and try and solve this on your own first, but I'm going to go ahead and solve it. So it's telling us that sine of b is 5 over 13. So let's take a look here. We've got b. Remember, sine is SOH, opposite over hypotenuse. So opposite, they're saying, is 5. And then hypotenuse, they're saying, is 13. And I know what you're thinking. What the heck, man? It says that this is 26. So remember the last problem where I said the ratio is going to be the same? The ratio is going to be the same. We know that the ratio is 5 over 13, but if the actual side is 26, then we just have to think, well, how does that relate to 13? It's twice 13. It's 13 times 2, right? So basically, if this is 26, which is 2 times 13, the actual length of AC should be 10, right? So just to clarify, the ratio is 5 over 13, but because the actual side is 26, we could think of it like 5 over 13 is equal to what over 26? You could cross multiply, or again, you could just kind of see that that's 13 times 2. So then you get 10. All right, so I hope that's clear. Now, what is it actually asking us? It's asking us what's the side length of BC. That's the one that we don't know. Well, again, we have a Pythagorean triple. And here's another tip for you. Memorize some of your basic Pythagorean triples. In particular, I would really memorize the 3, 4, 5 triangle. So that's a Pythagorean triple. Probably the most common that's going to show up on the SAT. We talked about the 20, 21, 29 in the last problem. And then this one is another example, which is a 5, 12, 13. And just like the last one, if you don't have that memorized, you would again use the Pythagorean theorem, a squared plus b squared equals c squared. In this case, one of our legs is 10, the other leg is unknown, and then the hypotenuse is 26. So you could either do it that way, or like I said, you know that it's a 5, 12, 13. So your number is 12, but then you have to multiply by 2 since everything else is being multiplied by 2. So then your answer should be 24. That's the actual side length here is 24. All right, let's do one more of these. One last time, I want you to try this one on your own first, using everything that we have learned so far, but let me go ahead and work through it. So again, we have similar triangles, which you should remember from one of the other problems means they have the same angles. So again, I'm going to do a quick sketch of these just to help myself visualize what's going on. And it says we have ABC. Does it tell us the right angle? C and F are right angles. Okay, so C, F. I'll do the opposite this time just to show you that that's possible. A, B. A responds to D. So that means D is here. E has to be up here. Cool. Tangent of A. Tangent of A. Remember, TOA. TOA is opposite over adjacent. So basically, this is pi. This is the square root of 3. So far, we've been able to just use a fraction to get our sides, but they're not giving us a fraction. So what the heck are we supposed to do? Well, we need to figure out what the square root of 3 looks like as a fraction. So what we can do is take the square root of 3 and we can multiply it by 1, right? Because that way we're not changing it. So what would that look like? Well, remember, we're trying to aim for a fraction. So we could just do 1 divided by 1, right? And that equals the square root of 3 divided by 1. So we didn't necessarily need to go through that process, but if you ever just get a whole number, remember that the number they give you is going to be the first side, and then your other side is just going to be 1, because anything divided by 1 is itself. So even though they gave us a whole number, we can simply say the square root of 3, and then we can call CA 1. Boom. Hope that makes sense. All right, and then it's telling us that DF equals 125. DF equals 125, and it's asking us the length of DE. The ratio from CA to BC is 1 to the square root of 3. So we could say 1 over the square root of 3, and this should be equal, because remember they're similar triangles, to, instead of 1, we have 125 over our unknown, which is EF. We'll just call that X. And my favorite thing to do in this situation is just cross multiply. So 1 times X is X, and then 125 times the square root of 3 is 125 root 3. And you are going to see in all the answer choices that we have, the square roots are not resolved. So we're going to leave that as is for now. So 125 root 3. And here's where things get interesting. So the way I drew these triangles is actually not accurate now that we're seeing the lengths, because the square root of 3 is going to be bigger than 1, right? Because if you think about it, the square root of 2 is 2, which is bigger than 1. So the square root of 3 is definitely going to be bigger than 1. So in truth, these should be our longer sides. And as soon as we saw 1 and then root 3, if you have your special right triangles memorized, you're going to recognize that this is a case, and I'll actually draw the triangle the proper way. So it would look more like this, where we have our short side is X, our hypotenuse is 2X, and our other leg is X times the square root of 3. Lucky for you, this is included in that reference cheat sheet, so you don't need to have this memorized per se, but it is good to remember that it exists, so that when you encounter something like this, you go to the cheat sheet. So if we follow these rules, our short side, remember I drew it wrong. So our short side is actually 125. Our short side is actually 1, which means our hypotenuse is going to be 1 times 2 for this one. So this, we know our hypotenuse is actually 2. And this would be 125 times 2, which is 250. So our answer is D, 250. We do hope you found some value in those tips. And if you're looking to really boost your SAT score, you might want to consider signing up for one of our small group courses. These courses are designed for those students who thrive in a more collaborative group environment. Courses are available with 12, 24, or 36 hours of expert instruction from one of our tutors. Each course includes 5 full-length practice exams and detailed score reports breaking everything down so you know exactly what you need to work on. Go ahead and use the link in the description to get signed up for a small group course with Revolution Prep right now.